Hello guys, this is Hamzat Talal Khan from channel HTK69. Today we'll be going to model spline in helical gear. So what does spline in helical act as? Spline in helical gear serves as the female part of the main spline gear. What we are trying to do is we are trying to model spline and the main gear mesh system. For the first part we have model the spline and the shaft itself, and in this part we are going to model the female spline in the helical gear, and in the third video, in my last video, we are going to assemble these two files. So let's start with the input parameters. These are the input parameters: spline diameter and spline number. Very easy video, just only two parameters we need to deal with this. Let's open the notepad file. Here you can see the parameters and the relations that we are going to use. There is no chamfer around in this part of the exercise. As I have told you, we need to just customize the existing helical gear that we have made in our previous videos. We don't need to make another gear, just we need to do some modifications to that previous gear. We will add some parameters to the existing parameters and also some relations to the existing relations. Of course, this file will be available in the description for you to download from. So let's open the gear that we have saved. Select open and select the gear. You may have a different name. Just select the previous gear that we have modeled, the helical gear. Click open. As you can see, the file has now opened. Before you do anything, just click on this pattern and hide this pattern. The reason behind hiding this pattern is that when we try to create the tooth profile for the spline, the pattern causes us problems while we try to create that exact profile. So we have done the hiding. Now we will also disable the coordinate display and the plane display. Now we will enter into the tools and enter our parameters and relations. First we will enter the parameters. Just go to the bottom of the parameters line and add these two parameters. The first one is the spline number. Spline underscore number. Add this number as an integer and give this a value of 16. Then add another parameter by the name of spline diameter. Spline diameter. Give this a value of 30 millimeters. Press OK. Now we are going to enter the relations. We are going to enter the relations at the bottom of the file. For that we need to select the relations, copy and paste them over here. We need to verify these relations. The relations have been successfully verified. Press OK and OK and close the prompt box. Now go back to model, select the front plane and select sketch. Go into the sketch view. We are going to sketch a circle. Give the value of diameter as spline diameter. Spline diameter. Press enter and exit the sketcher. Then we need to sketch another entity. Use the previous reference. Click circle and create another circle. This time give it the value of D. Simple, the letter D. Press enter and OK the sketcher. Give this sketch 4 the name shaft. Press enter. Now we are going to use this plane again. Use sketch. Go into the sketch view. Now we are going to sketch the spline teeth. For that, just follow my lead. Do as I say. Use the line command. Create a parallel line. Then create a horizontal line. Then use the 2D project and project this half semicircle. Close this prompt and now delete all the extra lines. that we have created. Now we need to construct a central line. This is the central line. Select the curve and the lines and mirror them over the central line. As you can see, our teeth profile is now complete. Just we need to add some values. Give the width as W, simple W, press enter, and the height as H, simple H. Now the teeth is complete. Press OK and give this sketch the name teeth. Okay, now we need to extrude the shaft and teeth separately. First we will extrude the shaft and the teeth. Select shaft and select extrude. We'll select the opposite extrude, the negative extrude, and select as surface extrude. Click on this surface. The system automatically extrude till this surface that you have selected and press OK. Then select teeth and select extrude. You also need to do the same thing, opposite extrude. Select the surface, select the surface that you want to extrude till and press OK. And now we need to pattern this extrude over the main axis. For that, select extrude 3, click pattern, select the axis, also click on the axis of the body, divide them over 360 degrees and enter the number of splines, that are 16. Press OK. As you can see, the splines are now generated by the system. Now we need to relate this pattern to the main parameters. For that, click on tools, then double click this teeth, click on relations, press enter, double click again on this teeth, click switch dimensions. When P38 or P something appears, this means that you have the correct dimension. Select this dimension. This dimension is now appearing at the bottom. Click equals to and write ahead spline number. Spline number. Verify this relation. As you can see, the relation is successfully verified. Click OK. OK and exit the main prompt. Now we go back to the parameters. We change the spline number from 16 to 5 to see if the parameters are related to the pattern. Select enter, select OK and regenerate the model. As you can see, the model is now regenerated. This is an indication that the pattern is now linked to the input parameters. Display all the datums and coordinate system. Now we roll back the changes. Click on parameters, roll down to the end and select 16. Roll back the changes. Click OK and regenerate the main feature. So you can also confirm whether the patterns are linked or not by clicking on pattern and clicking edit definition. As you can see over here, the pattern is blurred. We cannot edit it. This is because this number is now controlled by the input parameters. Click OK. Now our work here is done. We have created the spline in helical gear. In our next video, we are going to assemble spline in helical gear with the main spline shaft. Till then, good night. Have a good day.